Backpropagation in neural networks. AI intermediate level. Introduction. Neural networks learn by adjusting their internal parameters so that their predictions become more accurate. During training, a neural network receives input data, makes a prediction, compares the prediction with the correct answer, updates its weights to reduce the error. The algorithm responsible for updating the network's weights is called backpropagation. Backpropagation is one of the most important algorithms in machine learning and deep learning. It allows neural networks to learn from mistakes and gradually improve performance. Backpropagation is widely used in applications such as image recognition, speech recognition, natural language processing, recommendation systems, autonomous driving systems. Understanding backpropagation is essential for learning deep learning and neural network training. What is backpropagation? Backpropagation, short for backward propagation of errors, is an algorithm used to train neural networks. It works by calculating how much each weight in the network contributed to the prediction error. In simple terms, backpropagation equals an algorithm that adjusts neural network weights to reduce prediction error. Example concept. Prediction means error means backpropagation means weight update. The goal is to minimize the loss function during training. Why backpropagation is important? Neural networks contain many parameters, weights and biases. Without a systematic method, it would be impossible to know how to adjust them. Backpropagation provides an efficient way to compute gradients and update weights. Example concept. Large error means large weight adjustment. Small error means small weight adjustment. This process allows neural networks to learn complex patterns from data. Neural network training overview. Training a neural network typically follows these steps. Input data. Down pointing arrow. Forward propagation. Down pointing arrow. Prediction. Down pointing arrow. Loss calculation. Down pointing arrow. Backpropagation. Down pointing arrow. Weight update. This process is repeated thousands or millions of times during training. Forward propagation. Before backpropagation happens, the network performs forward propagation. During forward propagation, input data passes through the network. Neurons compute outputs. The final prediction is generated. Example concept. Input means hidden layers means output means prediction. The prediction is then compared with the correct value. Loss calculation. After the prediction is generated, the model calculates the loss. Error. Example concept. Actual value equals 10. Predicted value equals 7. Loss equals error between them. Loss functions such as mean squared error or cross entropy are used. The objective is to reduce this loss. Backward propagation of error. Backpropagation calculates how much each weight contributed to the error. The error is propagated backwards through the network. Example concept. Output layer error. Down pointing arrow. Hidden layer adjustments. Down pointing arrow. Input layer adjustments. This tells the network how each weight should change. Gradient calculation. Backpropagation relies on gradients, which measure how much the loss changes when weights change. Example concept. Weight change means change in loss. Gradients are calculated using calculus. Partial derivatives. Example representation. Frac, partial L, partial W. Where L equals loss function, W equals weight parameter. This value tells us how sensitive the loss is to a particular weight. Weight update using gradient descent. After computing gradients, the model updates weights using an optimization algorithm such as gradient descent. Weight update rule. W underscore new equals W underscore old eta frac partial L partial W. Where W O L D W old equals current weight W N E W W new equals updated weight. Eta equals learning rate. Partial differential L partial differential W partial differential W partial differential L equals gradient of loss. This update moves weights in a direction that reduces the loss. Backpropagation workflow. The full backpropagation process looks like this. Training data. Down pointing arrow. Forward propagation. Down pointing arrow. Prediction. Down pointing arrow. Calculate loss. Down pointing arrow. Backpropagation computes gradients. Down pointing arrow. Update weights. Down pointing arrow. Repeat until loss is minimized. This process gradually improves the model. Example. Image classification. Consider a neural network trained to recognize cats and dogs. Example concept. Image input. Down pointing arrow. Neural network prediction. Down pointing arrow. Prediction equals dog. Actual label equals cat. Down pointing arrow. Loss calculated. Down pointing arrow. Backpropagation adjusts weights. After many iterations, the network becomes better at recognizing animals. Advantages of backpropagation. Backpropagation provides several benefits. Advantages include efficient training of deep neural networks, automatic adjustment of weights, scalable to large models, works with many optimization algorithms. Example concept. Large datasets plus backpropagation means accurate AI models. Limitations of backpropagation. Despite its power, backpropagation has challenges. Limitations include vanishing gradient problem, exploding gradient problem, requires large datasets. Training deep networks can be computationally expensive. Example concept. Very deep network means training difficulties. Modern techniques such as ReLU activation, batch normalization, and advanced optimizers help address these issues. Concepts learned from backpropagation. Understanding backpropagation helps learners understand. Checkmark how neural networks learn from errors. Checkmark how gradients guide model improvement. Checkmark how weights are updated during training. Checkmark how deep learning models are optimized. Checkmark how modern AI systems are trained. Backpropagation is the core algorithm behind deep learning. Simple definition. Backpropagation. An algorithm used to train neural networks by calculating errors and updating weights to reduce the loss. Final summary. Backpropagation is a fundamental algorithm used in training neural networks. It works by propagating the prediction error backward through the network and computing gradients that guide weight updates. Using backpropagation together with optimization methods like gradient descent, neural networks can gradually improve their predictions. This learning process allows deep learning models to solve complex problems such as image recognition, speech processing, and natural language understanding. Understanding backpropagation is essential for mastering neural networks and deep learning systems.